Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Rich Gear here as well, your co-host with Doug, and we're going to talk about something which is, Doug is the expert in this. I will defer to him, even though I do a lot of the talking, as we all know, but this is Doug's bailiwick. He's the chemical guy. He loves chemistry, and the stuff he's got to say about it. We're talking about the hydrogen bond today, correct, Doug?
Yeah, the hydrogen bond is what I call the glue that holds the universe together.
See, I never heard it called that. That's good, okay?
And we owe our existence to an abundance of features of our chemical elements that is designed by God in perfect proportion to its role in sustaining life.
Right, okay.
And there are unique features of every element in the periodic table. And they all have roles to play in various chemical compounds that they produce. And the one such feature is the hydrogen bond. And hydrogen bonds are forces where a hydrogen atom is weakly attracted to an unshared electron pair of another atom, commonly oxygen. And
can I stop you just with what is like a strong or a weak bond? What makes it weak or strong? Can you answer?
I'm about to explain that.
All right. Okay, I got a little ahead of there.
The strong bond in water, for example, is where you have hydrogen. There's two hydrogens that are attached to oxygen. Now it turns out that they are at a 90-degree angle to each other, and where they bind on the oxygen. But that leaves two electron pairs in an orbit where they're associated, and they create a electrical charge. So the place opposite of where the two hydrogen atoms are is a hot spot which weakly attracts the other hydrogen atom that's next to it in another water molecule. And so it is this feature, it's sort of like a magnet, okay, where you have a positive and a negative charge, and they sort of connect together like that. But the stronger bond is the covalent bond between the hydrogen and oxygens. But then there's a third bond that connects those. It's sort of like the sticky notes that you have. That was an experiment that somebody was doing in 3M where they were trying to invent a different kind of glue. And it was too weak. It didn't amount to much at all to glue anything together, except somebody says, well, I think we can find a use for this.
Yeah, and sticky notes.
Notes.
They're still used, even in this digital world, they're still used. Yep.
And so it's this weak bond thing that makes water a liquid and not a solid.
So if it was solid, is that ice or is that something? Or what would it be?
Ice is where it you cool it down, it makes those bonds a lot stronger.
So would the solid? What would be a solid molecule? I guess what would it be? Would it be ice or something else?
Yeah, it'd be ice.
It would be ice. Okay, all right. Okay.
But it's not strong enough to where the heat of it at room temperature, it warms it up to the point where it's a little bit freer. Okay.
Okay.
And so it's that whole scenario that makes life possible.
So it's an oxygen molecule. I'm looking at your diagram down here, show it up there. It's a lot larger than the hydrogen. Is that the way it is?
That's what it is. It's quite a bit larger. The hydrogen atom is actually just a single proton with an electron
one around it. Yeah, I remember that from my science class back in the day.
But if the oxygen, what it wants to do is steal an electron. And so it grabs the electron and puts it in its orbit, and then the hydrogen just sits out there as a single proton.
Oh, really? Okay, all right.
And so then that hydrogen atom wants to is attracted to this other end of the oxygen, and it's that weak bond. It's just that little attraction that holds the water together as a liquid.
See, to me, water is sort of it's like an enigma in the sense that it's common. Everyone knows about it.
Yeah.
Without it, life is not even possible. But for life to begin, we've talked about this in the past too.
Yeah.
Water is a destroyer. It would never. You can never get life with water unless it was already alive. Unless we already had life, which needs water. Isn't that the way? Am I understanding correctly?
Yeah. Water is an enemy to the reaction that forms amino acids. But water is also necessary for the function of proteins to actually work.
Think about that. And the other thing about water, it's so amazing, is that you got two gases that are highly, I don't know whether unstable is the word, but they're flammable. They're and then you create, and when they come together, two hydrogens and an oxygen, you get something that's liquid. It's like, it's how. To me, Doug, you probably, maybe you understand the chemistry of it better than I, but to me, I look at it, I go, how do two things that are like gases produce something like liquid? And it's just, it fascinates me, Doug, because of all the uses that water is used for today. I mean, or for life to even be.
It's pretty much the universal.
It's
solvent.
Everywhere, you know.
And if you wanted to write a book about the chemistry of raw water, it'd probably take 400 pages just to touch the surface of what you could describe about it. Because you're talking about, the properties of acids and bases and pH. And all that is how it reacts with water. And if this weak hydrogen bond wasn't there would be no life. There'd be, just if you just change that one little particular thing, you would really change the whole dynamic of how life works.
Well, the thing about Doug, and if I'm getting ahead of ourselves, I'm looking at some of your other articles, Origin of Life, Critique of Current Scientific Models. You got a paper here, and most probable reactions among products of Miller, and we've talked about that on the show before. But it's always good to revisit it from time to time. But I always think about, and I touched on it a little bit earlier, the idea, and it's like everything in life, Doug. Everything in this planet is sort of without a creator, without an outside external creative God, which we call. I mean, you have nothing that you have that is in that we have. The molecules, the stuff that we have would be conducive to creating something that could be replicating and intelligent or volitional, if you will. It just doesn't. Water, as you said, is an enemy for life to actually begin, and yet without water, life cannot exist.
Well, let me explain that.
That's an enigma to me.
The problem with water, if you're trying to create amino acids and to create the peptide bond, is that you have to remove the water in order to make the peptide bond between the amine group and the acid group of two different amino acids. And this particular article that you have in front of you talks about Miller's experiments and the products that came out of it.
Oh, really?
And so
I didn't know there was anything like that. Actually,
it tells you what he ended up with. And basically, here are the products. You have mostly formic acid. You have glycine, which is one of the amino acids, and it's the simplest one. It's the one that's not doesn't have a three-dimensional. It doesn't have a right hand and left hand part.
Okay.
Then you have glycolic acid, which is not an amino acid. Then you have alanine, which is the second simplest amino acid.
Okay.
And then you have lactic acid, which is not an amino acid. You have beta alanine, which is it's a different form of alanine.
Okay.
And then you have acetic acid, and then propionic acid. Okay, those are all products of the Miller-Urey experiment.
Okay. Which
All
was
right,
done with
two of the amino acids out of 20 that it produced.
Okay, but the also thing is, it was done with, isn't it with a reducing atmosphere? Was it done
Yes.
with? Yeah, it wasn't an oxygen impregnated atmosphere.
Right,
It was something. Yeah. Okay.
And so they were trying to come up with a scenario that made sense that would, with lightning causing
Right.
the compounds being produced. And so I think that this is, I often say that it was a Miller-Urey experiment that caused me to consider God and become a Christian, you know, because I could see right from the products of what it was producing. And I was trying to make the peptide bond.
You were trying to go one step above beyond. Weren't you?
And I said, well, if you have lightning, well, you have to have more lightning because you got to make it combine together some way. And it really, what it did was the glycine and alanine, those the two that were produced by it. I did the experiment on that and it did nothing. You know,
well, you said over the years we've talked about it. Those who watch the show at all, brown sticky goo, isn't that what you made?
Well, the brown sticky goo comes when you zap the tryptophan and tyrosine, and those, of course, are two of the more complicated amino acids, which you can't produce this way, and so what it does is that they have aromatic rings that is fairly complicated, and so the lightning, when it hits that, it breaks those things down into, and I wasn't able to actually identify all the compounds that came out of it.
Really? Oh, really?
It was really not easy to purify what they had, but I did some column chromatography to separate them, and
now it's getting beyond me.
But it just after a while, I figured out that my experiment was a successful failure.
Okay, all right.
And that's where you learn something from your experiment.
Yeah, actually, that's good. Yeah.
And the hydrogen bond, though, plays an important role in the activity of proteins, because when it's sitting in water, which it does in life, it interacts with the chain of amino acids that are, and they can be up to 400 to 2,500 amino acids in this chain of protein, and there are different side chains to each amino acid. The side chains determine its activity because some of them are what's called hydrophilic, means that it has some of the OH, it has an OH on it, and it's this OH that creates the hydrogen bond.
So OH, is that oxygen, hydrogen? Is that
it's a hydroxyl radical, which is attached on the other end to the amino acid.
Oh boy. Okay, wow. Okay.
And so that
it's complicated.
That determines that it's hydrophilic, which means it takes the protein and those little side chains sort of waft out in the water, liking it, you know. There's other side chains that are hydrophobic, which means they don't like
water, so they go away.
So they will congregate together and bend the protein into a certain shape.
Oh, is this where you get into the three-dimensional nature of proteins?
Right.
Okay, yeah.
And if you take alanine and just put it into a polypeptide, it forms an alpha helix with the hydrogen bonds making a spiral.
Huh? So what's the purpose of that?
Well, that's something that you discover if you try to put these together into a chain of proteins. But it'll make this alpha helix. But these other bonds that I talk about, the hydrogen bond with the hydrophobic and hydrophilic, and then you have there's some ionic bonds where they they're attracted to each other by the positive and negative charge. Then there's a covalent
There's
bond.
all these different things that are going on at the same time. Wow.
There's a covalent bond between sulfurs.
What does covalent mean exactly?
Covalent means that they're sharing electrons.
Ah, okay. That's good.
And so the two atoms come together and the orbits go around each other.
Ah, the electrons are ones that...
And that's a more powerful bond. And there's double bonds and triple bonds
Okay.
where you just share more and more electrons.
Okay. Wow. Okay.
And so those make it possible for this to be bent around into a specific shape. And what happens with these proteins is that then they will take a food particle or something like that. You eat food, and it's going to create a way to grab that food particle, which also has the proteins in it,
Okay.
and it'll match it up so it breaks it apart into smaller units.
Is that for like
Digestion.
for digestion and nutrient and stuff like that?
Right.
Okay.
And so it breaks it down into pieces, into individual amino acids, so they can be used elsewhere in the body.
Then you have the product that's when you have stuff that's like bulk or stuff that's waste. How does the waste thing get out? Then it takes what it needs for nutrients to feed the cell or whatever it is, and then the rest of it is passed through the body.
That's right. It'll take that out, but all these different proteins have jobs to do, and not all of them are related to digestion or anything like that.
Yeah.
One of the things that it does is protein and DNA repair.
Ah.
And so there are proteins that are specifically designed for that. They've identified like over 600 of these in a recent article that was, and they were not able to figure it out unless they used artificial intelligence.
Oh my! Really?
Yeah, because they had to run the simulation with speed it up beyond the way that a normal human being can actually analyze it.
Okay. Okay, all right, and the AI could do that.
The AI could do that.
Wow.
And so
that's kind of scary.
So that they have these, but like I said, the hydrogen bond is like one of the main things that holds the glue to life together, and it's really amazing as you look at it because it really is something that I posted on one of the forums that if you studied only the hydrogen bond.
Was that a Freudian slip?
Hydrogen bomb.
Hydrogen bomb as opposed to hydrogen bond. It'll blow up on you.
Yeah, but if you studied the hydrogen bond, you really have no excuse not to believe in God, because that one feature of
just that one
feature should be sufficient for you to say, well, this is something that had to have been planned by an intelligent designer. There's really no other way that it could have happened, and so that is something that I think is really a compelling argument for me when I was going through chemistry classes many years ago. And discoveries that I made when I was doing this 50 years ago have really never been refuted.
Really?
I have studied this, and I came to these conclusions all those years ago, and I said, how can you not believe when you're looking at this whole thing? And I remember just about a month ago, somebody posted this thing. Well, we have sequenced the entire human genome. What have you guys done? This was an atheist.
Oh yeah, okay.
All right. In their arrogance, they said, we are able to figure all this stuff out.
Yeah.
Well, can you reproduce it and get your own dirt, okay?
Yeah. yeah. Now, Doug, there was one thing, and I don't know whether the hydrogen bond is about that, but you've mentioned over time there's a almost like an anticipatory. You mentioned the repairing thing. They can anticipate. Is that involved with any of this, or am I just far afield? Where they kind of it's almost like a fourth dimension, and it shapes proteins and things of that nature. And I may be getting far afield and jumping to something isn't really valid.
No, that's a good point.
Okay, but it anticipates,
Yeah, there is a three-dimensional structure to the proteins and to the DNA, but it changes with time, and that's your fourth dimension.
Yeah.
And so there are, based upon the needs that are in the body, if the protein is active and it's doing is producing certain things from the food that it's eating, then if it gets enough of it, then the concentration of it will bind on a different part of the protein and it shuts it off.
Oh, okay. It anticipates the need, okay.
And it's like a servo mechanism where, you have a certain thing, the product of what you're making, if it comes to a certain point, it's like if you're filling up a basin of water, and then there's a little drain that's on the top of the basin, it'll mitigate it overflling.
Oh, all right.
That'd be a very simple example.
That's a simple, okay, I got you.
And the thing of it is that origin of life experiments, that have, like the Miller-Urey experiment done in 1953, back when I was 3 years old, this has been touted as
proof of spontaneous generation, literally.
Proof of spontaneous generation, and yet if you analyze what comes out of it, and it's totally inadequate to explain life. And the more that you study it, the more problems you find.
Yeah.
And in Miller's experiment, you only find the two simplest amino acids produced, and they have to then take it on faith that the other 18 amino acids are produced also, and then in the sufficient concentrations and amounts and order, in order to, and then they have to put it together with the peptide bonds. And
let me ask you a question.
The peptide bond just doesn't work. Yeah.
So you got the two amino acids, but what about all these other byproducts? Are they?
That's your brown sticky goo stuff.
Okay, and I'm saying that is a mitigating factor for anything bonding together anyway, right? Or okay.
And what also happens is that the reagents that you use to produce the amino acids conflict with the reagents that you need to produce nucleotides. And nucleotides.
Okay.
Nucleotides are what you make DNA with.
I think it's better than this.
And so you have to actually set up a whole different experiment to produce your nucleotides, and that one is a whole lot more complicated, because DNA, it involves making phosphates, bridges, and if you try to build that in a chemistry laboratory, it binds it on the wrong place.
Oh my gosh! Okay.
And so they try to connect the nucleotides, the adenosine, thymine, guanine, and cytosine, and they get those connected like that. It becomes a real problem because it doesn't really work.
Okay.
And you just can't get the chemistry to work. And so, given that, I saw this early on when I was doing my own chemistry experiments, and I guess I wasn't arrogant enough to say, well, I'm smart enough to know what this is all about and understand it and try to figure it out, and that makes me kind of like God, and so I.
Oh yeah, well,
don't you
think that's part of the whole deal? I mean, they're trying to do these things to show that we are all there is, and therefore we're God. Doug, you got something here. The origin of life, a critique of current scientific models. Did you want to talk about that at all, or not, or do we have time?
Well,
Does that relate to what we've been talking about?
It was related to it, and I'll read the abstract of this.
It's kind of interesting, you know.
Yeah. Profound advances in the fields of molecular biology in recent years have enabled the elucidation of cell structure and function in detail previously unimaginable. The unexpected levels of complexity revealed at the molecular level have further strained the concept of the random assembling of the self-replicating system. And so they also talk about, they find, and they were talking about cyanobacteria, which is what they find at the bottom of the ocean.
Oh yeah.
At the sulfur vents.
Oh the
and
steam vents.
So they think that that's the origin of life, and then they actually try to explain that that's something that where we evolved from. But then they have to explain where we had the great oxygenation event.
Yes. Oh yeah.
Because because the scenario to produce life in the test tube needs to be absent of oxygen. Well, you have oxygen in water, and you have hydrogen in water, and
even even the rocks at these deep timers, it's all impregnated with oxygen.
Right.
So where or when would you have had the time where there was no oxygen? It doesn't seem to exist in
that's what that
geology.
article talks about, is that they go back and analyze the rocks that were supposed to be produced at that time.
Yeah.
And it's all full of oxygen, and the whole scenario that they are trying to replicate so that their chemistry works, kind of.
Yeah. Even with their chemistry, with the way they set it up, it doesn't work.
Yeah.
But the way it really is, it could really never work.
That's right. And so the whole underlying assumptions of the origin of life experiments it really shows that there's this arrogance that say that we can explain all of this. So if you just give us enough
It's all
time.
predicated on a false premise, and it all is based on the idea that we are God. Or, if you will, let's go back to the Garden of Eden. Did God really say he did it this way? And they basically reject that premise, and so you got to substitute something that really doesn't work at all.
All right, so you evolutionists, you go get your own dirt and show us how it's all done, because your own experiments show that it falls short of explaining how life got here by chance.
Amen.
We'll see you next time on Revolution Against Evolution.